This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber. This is our first episode of our Eindhoven special. Why an Eindhoven special? Eindhoven has developed into a powerhouse for industrial AI in Europe, driven by companies such as Philips and ASML. A lot of money has been invested in the university and many companies are benefiting now. Today, I'm talking to Albert van Breemen. He's the CEO of VBTI, and hardly anyone else in Eindhoven symbolizes the Eindhoven ecosystem like he does. Dag Albert, please introduce yourself and your company to the listeners.
Yes, hi Robert. My name is Albert van Breemen. I'm the founder of VBTI. VBTI is a young company here in Eindhoven. We exist now for 5 years, and we are focusing and exploring deep learning technologies and how you can apply it within the high-tech industry.
Mm-hmm. And you work for Philips, you work for ASML, right? You are a kid of the ecosystem, right?
Yes, I studied electrical engineering in the 90s. And actually, when I started my study, I was already using neural networks. Also a PhD on artificial intelligence and control engineering. Then I came to Eindhoven in 2001, worked for 8 or 9 years for Philips Research within the ambient intelligence program. So we were exploring how you can use artificial intelligence for consumer electronics. And in 2010, I moved to ASML, where I worked 10 years for the new business development department, exploring many new technologies, not only artificial intelligence, but all kinds of technologies, and finding out the market opportunities for the company and making new business proposals.
But today we are talking about first the food industry, cucumbers, and your platform. And I call your platform, it's the AI gym, and we will talk about the gym, the AI gym later. But let's start with a use case. What have you done with cucumbers in the food industry?
Yes, well, actually, I never thought that I would end up in the world of plants and agriculture and food.
But you are from the Netherlands, right?
I'm from the Netherlands, but I really love technology. I love gardens, but mainly to sit in and read books and not really to work with plants. But there is a perfect match between deep learning and plants and agriculture. And because one of the longest projects that we have been working on is a project where we develop a computer vision system for a leaf cutting robot.
A leaf cutting robot, okay.
Yes, so this robot, if you look at the production of cucumbers in the Netherlands, a lot of the production is going on in greenhouses, and a lot of labor is going into maintaining your plants and cutting the leaves of cucumber plants. And actually every 2 days you need to cut away at the lowest part of the plant all leaves to keep the plant in balance concerning how it is dividing its energy over the plant. And my customer had a vision that they wanted to make a robot that replaces the manual labor with a robot.
But I think that's very difficult because nature is unpredictable. Every leaf can look different, right? So it's quite difficult to use a computer vision approach there.
It's a very, very difficult problem. And that's also the reason why we have now working on this problem for 4 years.
4 years, okay.
4 years, yeah. So if you look at machine vision, then traditional machine vision works perfectly in a manufacturing environment where all objects are the same. If you have seen one metal part, then you have seen all metal parts because they are all the same. And there is a lot of machine vision technology for those type of applications in the area of manufacturing. But exactly what you say, if you go to a greenhouse and you have look at one cucumber, then the other cucumber is different. If you have seen one leaf, the other leaf is different. And that's also, in my opinion, the reason why we have not yet all kinds of automation in greenhouses, because traditional machine vision is not able to really deal with the variation in cucumbers, in leaves, in the visual scene. And that's the difference with deep learning, because deep learning technology is a technology where you first need to collect a huge data set of your environment. And then with the deep learning algorithms, it's learning actually how to recognize those variations. And the deep learning technology that we currently have is now able to remove this vision bottleneck that we have had for years in agriculture. Because now we can train computer vision modules that can recognize all types of leaves and cucumbers of different variations. Because if you have sufficient data, it will learn to recognize those objects.
Please share some insights with us. What kind of images we talk about? How do you proceed? And how many pictures did you take? And how do you also use synthetic data? Do you need 3D images of the leaves and the cucumbers, the plants? Please go a little bit more insights.
Okay, well, actually, we did it all.
Okay. Thank you.
But if I go back to the start of the project, so how did we start? The first start was, well, we just took a camera and we went to greenhouses and we took pictures manually ourselves. To train a deep learning model, nowadays, you need a data set of a few thousand images. When we started 5 years ago, actually, the research community said you need more data. And that's the interesting part with being now in this field of deep learning. Every year we have new inventions. One of the new breakthroughs, for instance, that happened is a concept called transfer learning. So what is transfer learning? You can train a deep learning model to recognize, for instance, to recognize cars. So we have a domain where somebody already trained a model on a huge data set of cars and has trained a computer vision model that recognizes cars. So what you now can do is I can copy that model, I can modify it a little bit, I remove a part of the model and I add a new part to the model. And then with a little information from greenhouses, let's say only a few thousand images, I can tune my model that was first trained to recognize cars, now to recognize cucumbers.
But how accurate is this approach?
I can make it as accurate as I like, as long if I have sufficient data for my application domain. So what you typically see is that if you train your first model from scratch without any, let's say, prior information, then typically you need to have a data set of millions of images to come to a good model. But if you use this concept of transfer learning, actually you only need a few thousand images to train a model that is already operating good enough.
Please go on. Okay, you said, okay, we choose the transfer learning approach. What happened then?
Yeah, so we went to the greenhouse, we collected data.
By your own, right? With a camera?
Just with the camera by hand, and then we needed to annotate the images.
Exactly.
So what's annotation?
Yeah.
Before you can train a model, somebody, a human, needs to point in the image, this is a cucumber, this is a leaf, this is a stem. And so we also did that manually. And then we had an annotated data set. And with an annotated data set, I can start training my computer vision models with deep learning.
Did you use a state-of-the-art model, computer vision?
That is always relative. So for that time, it was state-of-the-art.
Okay.
But we started 4 years ago, and I can always say that what is state-of-the-art now is next year not state-of-the-art anymore.
Exactly.
Developments in this field really goes very fast.
How do you handle this problem?
And well, in the beginning, we were a little bit taken by surprise because we started to train a model. And now I explain you the 4 steps: data collection, annotation, training a model, and then deploying it, using it. But actually, you're never done. You constantly need to collect new data because you want to collect all those variations in cucumbers.
Exactly. You need an MLOps pipeline, right?
You need to have an MLOps pipeline. So we started to invest ourselves in a software platform that makes us independent of all these technology changes that will happen. And this platform we call 1DL.
Yeah, that's the gym. We will talk about the gym later, yes.
Yes, it's a gym for models, for keeping models fit. And what is the idea behind 1DL? So we first created an abstraction layer over data types, and we also created an abstraction layer over all kinds of what we call a model trainer. You have many different deep learning frameworks like TensorFlow, PyTorch, detection, Ultralytics, SuperGradient. And what we did is we created an abstraction over those frameworks, which makes it now possible that if I want to switch between a framework, actually my switching cost is really reduced. And I have a very nice anecdote. When we started 4 years ago, I was working with my colleagues on training models. And then my colleague said, hey, I trained a new model to detect the stems of cucumber blends. And I asked my colleague, can I get your model and run it on my laptop? And the answer was no. And it was very surprising for me. Why could I not use a model? And then I learned that before you can use a model, you need to install many software dependencies on your machine. And that means that actually, as an AI engineer, you not only need to be knowledgeable on AI and models, but you also need to be knowledgeable on Linux, on installing drivers, so doing the DevOps of your machine.
Exactly. So do you use the Onyx standard, or what is your standard?
We use everything. We support everything. We also use ONNX. It really depends on what is the application and what are the hardware requirements, because that's the other thing that we learned. So if you train a model on your laptop or on your workstation, that does not mean that you can use that model also on an embedded device that will end up in your robot. So you need to convert. And then again, you get back to these two roles of, you have AI engineers that understand the application and algorithms. And you also have the software engineer and the DevOps support for actually supporting your system. And that are two different roles. And finding somebody who understands two roles is very difficult. And that's why we developed a platform to support the AI engineer, so that the AI engineer does not need to think about any DevOps and driver installations and etc. And only can focus on developing the AI models.
I want to come back to your camera and to the cucumbers before we talk a little bit more about the platform. Was the quality of the images sufficient for you? Sufficient enough?
Yes, so that's interesting. We in the end now, over the last 4 years, we collected data with, I think, maybe 5 different cameras. And actually, because they use different cameras with different optics, we now have also variation over the cameras. And deep learning loves variation, because the more variation you have in your data set, the better your model can generalize. And it is always this trade-off between the quality of your optics and the resolution of your images. But our learning is the more variation is always better in the end. You really can make a model that can generalize over different situations.
One more question. Did I understand you correctly? You have developed your own model and then combined it with a state-of-the-art model? Am I wrong?
No. But we did develop it by now. So when we started, we used open source models and architectures. That is nice if you are doing research or if you are an academic and want to explore these models. But once you need to apply models for a customer in an industrial project, then also the licensing of the models becomes very important. And also whether you can change the codes so you can fit software on a specific hardware platform. And for that reason, we noticed that when you indeed want to integrate deep learning models into a commercial product, for a company like VBTI, it is very valuable to have our own model IP. So we now have developed our own object detection models, classification models, segmentation models, which is our IP. And with that, we can help our customers to be independent from other licenses from deep learning frameworks.
So let's come back to your model. You mentioned the cameras, the different qualities. What about 3D models or images or synthetic data? How do you get around the problem?
Yes, so if you data is in the end your bottleneck.
But you have a lot of cucumbers there, so no problem.
No, but the problem is that I need to send somebody to a greenhouse to collect data. Then the problem is if I give my system to my customer and my customer starts to sell the machine to a greenhouse where I have never been. It means there is data or the scenery that was not part of my data set. So my advice is always, if you start in a project, in particular in projects where you will have multiple products or machines that use your model, you always need to bootstrap. Bootstrapping is, you can even just take your iPhone, go to the situation, take images, annotate them, and train your first model. But once you are building and integrating your model in an application, always add a data collection feature in the machine itself. So the leaf cutting robots that we are now building always have a data collection possibility, because then in the end, you will get the collection of data, you will get it for free. You will lower the cost. And the only cost factor that you then will have is you still need to annotate your data, which is a huge cost factor in projects. But the first one, the data collection, you can actually automate it if you integrate it as a basic functionality of the product that you are making.
But how reliable is the model? What is your approach? How reliable is it?
Yeah, so I give you 2 examples. So we have one customer where we make a model for detecting asparagus.
Okay.
That model has an accuracy.
And this is easier, right?
That is a little bit easier. There's never an easy problem when you integrate a model into a machine that works and operates in the real world.
Yeah. Okay.
Things are easy if it stays on your computer and it's only for analysis. But once your model starts to control a physical machine, things are difficult. And with the asparagus, in the end, we are now at 95% accuracy that we detect all asparagus. And this season, we actually collected more than 4 million data points from the machines that are active in the field. So we expect now an asparagus season is only 3 months. And currently it's over now in June. And we expect now that with this big data set, we can just improve and go maybe to 98 and 99% of accuracy. If you look at the cucumbers, where you actually need to cut the leaf of the plant, there the problem is more difficult because you need to detect the full main stem of the plant in order to avoid cutting the main stem. And actually that problem is not solved only by deep learning. So there you see that we integrated deep learning models, but we also integrated it with our own heuristic algorithms.
Oh, that's interesting. How did you do that? Combining both worlds?
Yes. How did we combine? How can I explain that in an easy way? Well, if you look to a plant, then you could say a plant is a chain of nodes and stems.
Exactly. Okay.
And if you have, that look like a graph. Well, if you go back with artificial intelligence to the 50s and 60s, there were a lot of algorithms developed for searching graphs. And deep learning technology is technology that analyzes objects in an image. So we use the deep learning technologies to find the nodes and the stems. And then we use these traditional search algorithms actually to find how they are chained together. And if you combine those 2 algorithms, then you get a system that just analyzes an image and gives you back what we call a plant model, which in the end is a chain of nodes and stems.
Hey, that's interesting. That's a really interesting approach, right?
Yes, it really helped us because now we are, last year, we had, let's say, 1 out of 100 plants, we made a wrong prediction. So we said that a main stem was a leaf stem. And our target for the robot is 1,000 leaves per hour. So that would mean we would cut 10 plants per hour, which is really not a good business case for the grower. But currently with this new approach and this new insight of combining the search algorithms, traditional search algorithms with deep learning that analyzes the image, we are currently at a situation that the machine first needs to run for several hours before we see the first main stem cut. And then improving still the accuracy of the system, in the end comes down that you always need to monitor the performance of a deep learning system, and you always need to collect new data, and then you continuously need to retrain and update your model. And that actually is what you call the gym.
I want to come back one question about the edge, because you mentioned the edge. Does the model run on the edge, and how does the communication to the gripper work? Is it a ROS-based robotic solution, or do you use an other operating system?
Yeah, so my company is responsible only for the vision part.
Okay, sorry.
So we develop a lot of our software on Python, and we deploy it on an embedded system. It's an ARM-based system with some NVIDIA AI hardware accelerators. But the robot software now is indeed implemented on ROS and just interfaces with our software with our own protocol.
But you need the compute power of NVIDIA, right?
Yes, we need a lot of compute power. We never have sufficient compute power, by the way.
Okay. But isn't that crazy that every robot now needs a NVIDIA compute power? Is it possible to build smaller models, less compute intense?
Yeah, so if you look at training a model, then training a model is not a very direct process. You always need to do a lot of training, which we call to do an experiment, and then just compare empirically whether your model is working better. You can make models smaller, but you always need to investigate what's the impact on the performance of my system. So, for instance, if I make my model 4 times smaller, would I then cut more often a main stem? And that's always something you need to investigate. And that's also something that we have built into our 1DL platform. So if you make a model, it's not that you work on one specific model. Often you do 100 of training jobs, and you need to compare all those models given to a specific reference data set, and then select a model that just worked best for that data set. And it can very well be the case that one model works good on a data set that you collected in greenhouse A. And if you have the data from another greenhouse, that you maybe need to have another model that's optimized for that situation over there.
You mentioned to transfer this approach. You mentioned other food or agriculture domains. Can you transfer your knowledge now, your domain-specific knowledge, your model to other industrial problems? Is that possible?
Yes, so you see a few generic components.
Because you solved a big problem, right? I think it's a very interesting problem you solved.
Yes, so I'm happy that we could start with the most difficult problem we could ever imagine. Because if you see a leaf cutting robot at work, it's really amazing that just an autonomous device is able to find in this jungle of leaves and stems the right position to cut a leaf. So often in deep learning, you see these simple examples of, okay, we need to classify an image into a dog or a cat, or we need to detect a car or a person. It's easy technology nowadays and easy to develop, and everybody can do it. But if you are in this area where we are using 4 cameras, so we have 3 overview cameras, we have 1 camera at the gripper that is moving when the robots move. If you have the problem of not only detecting the objects in your image, but you also need to determine the 3D location of the object, and knowing that you need to control the robot, that is the most challenging problem that you can work on. And currently we have had so many lessons that now we have a technology basis actually also for other type of robots. So if we need to develop a harvesting robot, for instance, to harvest tomatoes or peppers, we can use the same technology base. The only thing we need to do is we need to not collect data of cucumbers, but now we need to detect the peppers or the tomatoes and also define a different robot action. This time you don't need to cut, but maybe you need to grab something, and that's it. So I think we solved maybe 80 or 90% of what it means to develop a leaf cutting or harvesting robot for agriculture.
You already mentioned the gym. Let's talk a little bit more about the gym. Can I just buy your platform, or is it only for existing customers, or do you want to scale it with a software product now?
Well, actually, we are currently in a phase where we are making our product proposition. So we are not sure what is the best approach. And what is the difficulty? Difficulty is that when we started 5 years ago, it was predicted there would be a big boom and everybody would do deep learning. But in practice, actually, I see that many companies still find the technology very difficult. They do not fully understand on how to use it and how to apply it, and they just need support. The one thing I did learn is that there are many companies, particularly if you go back then again to manufacturing, who do not want to put data on the cloud, but they want to have it on-premise. And that is the reason why we currently say we always look per customer, per project. So if we have a new customer, for instance, who wants to harvest, for instance, blueberries, then we say to the customer, we can install the 1DL platform either in the cloud or on a server on your premise. And we make that platform really dedicated for your blueberry harvesting machines. We install our software on the harvesting machines and we connect it to your platform. And we can actually provide AI as a service. Our team can help you with maintaining the DevOps, so maintaining the platform that keeps running. Also, our AI engineers can help you with tuning the models, that you always have the best models. And you only need to keep your machines running and keep the data flowing into the platform so we can monitor the performance of the models.
What are your next plans with your company, with your platform or with your system integration part?
Yeah, so for the last few years, we really worked on developing the technology and the platform. And now we are ready to roll it out into applications. So we are really in a phase where we really would like to meet new customers who are working on a robot and need a vision system.
What is your USP compared? We have a lot of vision systems. When I look, for example, on the German market, wow, a lot of people working on vision systems. What is your unique selling point?
Yeah, so our unique selling point is that we have a vision system that actually is supported by a cloud infrastructure to keep the performance of the system always at the maximum.
So the combination of platform and vision system.
Yes. So I think if you talk about a vision systems, then traditionally you just think about, okay, it's a hardware device, it's a camera with a computer vision algorithm. And that's it. But actually, when I talk about a vision system, that means that it is a system and also hardware. With a camera, but also with an AI hardware acceleration, so you can run deep learning models on the camera. Next, the camera is able to collect data and send it back to a platform. On the platform, you can manage a fleet of these cameras, because that is where the power comes from. It's not that we have one instance of our camera. No, we have a fleet of robots that are using the models. They all send the data back to a platform. We can monitor the performance of all these models, and we can automatically retrain models and update all models or all machines with a new model.
And you don't care about the camera, right? It doesn't matter. You can work with different companies. Is it an IDS imaging company, IDS, or what else?
That is correct. We indeed, any camera is good because the company actually has two parts. We have an engineering team that always make a custom solution for our customers. And then we have this team that is building this 1DL technology platform.
And they communicate with each other. And so it doesn't matter which camera do the customer use.
No. And as I said in the beginning, we developed a data abstraction layer. So what does it mean? We started with normal RGB cameras. Then we had a project where we had an RGBD camera. So we also measured the depth. So we created a new data type, which has not 3 channels like the RGB, but also the 4th for the depth. And it just easily integrates in our framework, and we can even now develop deep learning models that takes not only 3 channels, but 4 channels as input. So if I would now encounter a new customer who says, well, I have a hyperspectral camera with maybe 128 channels. So the nice thing is that in our platform, we just define a new data type for this type of camera, and everything that you do with data sets, copying, sharing, training models, etc., all stays the same. So, and that is what I meant with the switching cost. If something changes in your, let's say, underlying technology, whether it is a new deep learning framework, or maybe it's a new data type because you have a new type of camera, that has become more or less plug and play.
So it is a bit an AutoML approach, right?
Yes.
But it's more than the one AutoML approach, right?
Yeah, so actually we called our platform in the beginning AutoDL.
Mm-hmm.
Unfortunately, we could not use that name, and then later on we turned it into 1DL. But it is indeed an AutoML concept where we added 2 things. That is, we added a benchmarking tool where you can benchmark different models that you have trained and then just pick the model that is the best fit between the hardware platform of your machine and where your machine is operating. And we have a monitoring tool, which actually helps in just keeping track of the performance of your model. And just to give a simple example, because sometimes people misunderstand this, a deep learning model in itself is not becoming worse because it's software and the software is stable. What changes is the data. So if I am, let's say, take the asparagus example. In the beginning of the season, the soil is very clean and I can train a model for that. But later on in the season, it can be very rainy, it can be a lot of weed. And if those type of situations were not part of my data set, then you will just see that the model will just perform worse on the new data. And that is the reason why at that moment, we can collect the data from the new situation and actually update the model to make it fit for the new situation.
Now you have a platform or tool for vision models. When will you build a platform for time series?
Yeah, so that actually, I think it's a business strategy decision.
Because that's the holy grail.
Time series, language models.
But in industry, in the industrial sector, I think when you have a platform combining AutoML, a gym for your models, and based on time series, then you are done, I think.
Okay. Well, actually, then I have to admit that the most customers that I encounter, they came with a vision question.
Sure, yeah.
So we worked on that part. We will turn our platform, make it ready for time series data, as soon as there's a customer who we can work with. Because there is not really, let's say, a fundamental reason why the platform cannot be made ready for time series data.
You said the world changes every year dramatically. What do you see coming in the computer vision?
One of the things that had an impact, made people think, is the concept of a foundational model. So I already explained transfer learning. So with transfer learning, what you actually do is you take a model that is trained on a specific data set, and then you dissect the model and reuse parts of it. With a foundational model, actually are models that are trained on even bigger data set, which does not know the labels of the objects in images, but it is able to already divide an image in meaningful objects. And that's interesting because if it can do that, then you only need to click once that you say, okay, you made this division, but this part I call a car, and then suddenly it can detect cars in many images. Foundational models are really big, so they cannot be applied to embedded systems. And what you typically see is that you use a foundational model and then to generate data to make a smaller model that fit on your embedded device. So foundational models, that is one of the technologies that we investigated in, also to reduce the cost for annotating data. But what you see is that as soon as you are entering a niche domain where you're not looking at the dog, the cats and the cars, but really at, for instance, scratches at high-tech parts that are manufactured, then it becomes already difficult with foundational models also to actually reduce annotation costs. But we are still exploring. And the other impact that we see is, of course, the generative AI. Generative AI are models that generate data. And instead of going to a greenhouse, you could, for instance, develop a model that generates images of greenhouses. And if you do it in the right way, then actually you get the annotation of the image as a bonus. And we did not yet discuss it, but actually the annotation is really the bottleneck currently in this whole technology. Because in our experience, if you outsource annotating an image, then for instance, placing a single bounding box will cost you 10 cents, which is the cost of placing a bounding box, but also the quality control of the bounding box. And for instance, I have had projects where I had 100 objects in one image, and then the annotation cost of a single image will be 10 euros. I asked to my customer, I would like to have 10,000 images to train a decent model. So that means you need to have an annotation budget of 100,000 euros. And that is the learning that we have had. And we see that back in all projects. So this annotation budget is really something that you need in your project. But if you have a generative AI, you can do without annotations. And that is something that the community is currently, the research community is really exploring, that with a very limited set of data, maybe 100 images, can I create a model that generates for me new data with annotations that I can use to train an object detection model?
I highly recommend the episode with the CTO of Schunk. It's a grasping solution. They use the Gen AI approach, not exactly for this, but it's in this direction. So I highly recommend this episode with the CTO of Schunk. I think 3 or 4 episodes behind this episode. Albert, I have one more question because you mentioned these foundation models. What will all the startups then do with their quotation marks, super customized vision models? Because then is everything commodity. What happens then?
That's a good question. I think how I look at this is that I see always the value of my company, that we understand how to integrate deep learning into a practical application. So my people are people with an engineering background, electrical engineering, mechanical engineering, who then started to use AI. So I never decided to be a pure software company exactly for this reason. Because if you currently have an algorithm or a service to train models, maybe the next year there is a new technology that completely removes your software team. And what will not be replaced is
domain-specific knowledge, right?
Domain-specific knowledge. Having people who understand what it means to have a physical machine, what it means to have a camera with all its limitations, and how to integrate AI algorithms there. So I think that is where I see a lot of value. The other part where I see a lot of value is that in the end, if you own the niche data, if you have a model that is not generic,
the cucumber model, right?
Cucumber model, or if you have algorithms that are not standard, so the plant model that we developed for finding the main stem in a plant, then you have unique IP that somebody else does not have.
Albert, thank you very, very much for these unique insights. All the best for you and your companies. It was a pleasure, and greetings to Eindhoven.
Okay, thank you. It was a pleasure to give this to do this podcast.
Thank you very much, Albert. Bye-bye.
Bye.